Hello viewers, welcome to IIT PAL Mathematics channel. This is lecture 5 on integral calculus. Today we are going to discuss some problems on differential equations. So, let us start with first some methods for solving first order ordinary differential equations. So, what is a first order ordinary differential equation? This in explicit form this is an equation of the form dy dx equal to f of x y, where x is the independent variable and y is dependent on x. So, dy dx is the derivative of y with respect to x is equal to some given function of x. F is a given function of two variables. So, this is explicit form. Sometimes the equation is given in implicit form. So, in implicit form, a first order ordinary differential equation is any equation of the form some function capital F of x, y and dy dx equal to 0, where f is a given function of three variables. So, let me just remind you some methods of solving first order ODEs. Solving first order ODEs. So, the first simplest method is the method of variable separable. So, in this method, suppose the given ordinary differential equation can be written in the form f x dx equal to some g of y dy, then we can simply integrate both sides. So, we will write integral of f x dx equal to integral of g y dy. This gives solutions in implicit form. if possible, we will write y as a function of x. So, this is the first method where you can separate the x and y variables like this. Second method is what is called homogeneous. So, this is an ODE of the form dy dx equal to f of y by x. So, if I can write the equation in this form, where the derivative dy dx is some function of y by x, then in such cases we can solve this by substituting y by x equal to a new variable u, that is y is equal to u x. So, if y is equal to u x, then what is dy dx? Dy dx will be equal to u plus x du dx. So, therefore, we get u plus x du dx is equal to f of y by x is u, f of u. Now, you can see that this becomes a variable separable ODE in the variables x and u, is same as x du dx is equal to f of u minus u, or du by f of u minus u is equal to dx by x. Now, integrate both sides. And finally, we will put u equal to y by x to get the solution. So, the third method that you need to know is how to solve linear first order ODEs. So, a linear first order ODE is of the form dy dx plus px times y equal to g of x, where px and gx are given functions of x only. So, in this case, to solve this, what we do is, if we multiply this equation, so if we multiply the given equation by e to the power of integral of px dx, then the left hand side becomes, so the left hand side will be e to the power integral px dx times dy dx plus px times e to the power integral px dx times y, and now you can see that this is nothing but the derivative d by dx of e to the power integral px dx times y, because by product rule if you differentiate this product you will get the exponential of integral px dx times dy dx plus y times the derivative of e to the integral px dx will give you e to the integral px dx times the derivative of the exponent is simply px. So, now this equation, so the ODE becomes d by dx of e to the power integral px dx times y is equal to e to the integral px dx times g of x. So, now we can simply integrate this. This implies e to the integral px dx times y is equal to integral of e to the integral px dx times gx dx plus an arbitrary constant c. Thus, we get the solution. So, this factor that we multiplied e to the integral px dx, this is called integrating factor. So, here e to the integral px dx is called an integrating factor. So, what we do, first we calculate an integrating factor and then we find the solution. So, let us now do some problems based on these methods. So, let us start with a simple problem. Question 1, if y equal to y of x satisfies the differential equation eight root x times square root of 9 plus root x dy equal to square root of 4 plus square root 9 plus root x, this inverse dx for x greater than 0 and y at 0 is equal to root 7, then find the value of y at 256. So, here if I write dy equal to 1 by square root of 4 plus square root 9 plus root x times 1 by 8 root x times square root of 9 plus root x dx. So, we see that this is of the first kind variable separable equation. Now, we just integrate both sides. So, this will give y is equal to the integral of this. Now, how to integrate this? Suppose we put u equal to 4 plus square root of 9 plus root x, then du is equal to, the derivative of this will give 1 by 2 square root of 9 plus root x times the derivative of 9 plus root x is 1 by 2 root x dx. So, we see that we get du equal to this. So, now integrating this we get y is equal to integral of 1 by square root of u times du by 2, and this is equal to square root of u plus c. So, y is equal to, putting again u equal to this, we get 4 plus square root of 9 plus root x plus c. Y at 0 equal to root 7, we get c is equal to 0. So, therefore, y at x is equal to square root of 4 plus square root 9 plus root x, and now we can easily calculate y at 256 will be equal to square root of 4 plus square root 9 plus square root of 256 will give 16, and then this becomes square root of 4 plus 9 plus 16 is 25, square root gives 5, and this gives the square root of 9, which is 3. So, that is the answer. Let us do second problem. Let f from R to R be a differentiable function such that f of 0 equal to 0 if y equal to f x satisfies dy dx equal to 2 plus 5y times 5y minus 2, then find the value of limit x approaching negative infinity of f of x. So, first we will try to solve this ODE. So, we have dy dx equal to 2 plus 5y times 5y minus 2. So, this can be rewritten as 1 by 5y plus 2 times 5y minus 2 dy equal to dx. So, again this is variable separable equation. Now, we integrate both sides. Now, this can be written in partial fractions. This implies we can write this as 1 by 5y minus 2 minus 1 by 5y plus 2. If we do, then we get in the numerator 4. So, 1 by 4 times this is equal to the integrand here. So, this dy equal to integral dx. So, this gives 1 by 4. The integral of 1 by 5y minus 2 will give 1 by 5 times natural log of mod 5y minus 2 minus this is 1 by 5 natural log of mod phi y plus 2 is equal to x plus c. So, if we multiply by 20, this gives natural log of mod phi y minus 2 by phi y plus 2 is equal to 20 x plus 20 c. Now, we are given that y 0 is equal to 0. This will imply natural log of, if we put y equal to 0, 0 minus 2 by 0 plus 2 mod equal to x is 0. So, 0 plus 20 c. This implies c is equal to 0. So, therefore, log of mod phi y minus 2 by phi y plus 2, this is equal to 20 x, which implies mod of phi y minus 2 by phi y plus 2 is e to the power 20 x. Now, suppose L is equal to limit x tends to minus infinity of f of x, then if we take the limit as x tends to minus infinity, then we get 5 L minus 2 by 5 L plus 2. This mod is equal to limit x tending to minus infinity of e to the power 20 x, and this limit is equal to 0. So, this implies 5 L minus 2 equal to 0, which implies L is equal to 2 by 5. So, the limit x tending to minus infinity of f of x is equal to 2 by 5. Let us do problem number 3. So, it is given that a curve passes through the point 1 comma pi by 6 and let the slope of the tangent to the curve at any point x comma y be y by x plus secant of y by x for x bigger than 0, then the equation of the curve is, you are given 4 options. A is sine of y by x equal to natural log of x plus half, b cosec y by x equal to log x plus half, c secant of 2 y by x equal to log x plus 2, and d is cos 2 y by x equal to log x plus half. So, we know that the slope of tangent at a point x comma y on the curve is given by dy dx. So, we are given dy dx is equal to y by x plus secant of y by x for x bigger than 0. So, we see here that dy dx is given as a function of y by x. So, this is a homogeneous form. So, we put y equal to u x, and then we know that this dy dx will be u plus x du dx equal to the right hand side y by x is u plus secant of u. So, u cancels and this implies x du dx is equal to secant u, which implies cos u du equal to dx by x. By integrating this, we get sin u equal to log of x plus c. X is given to be positive, so we do not need to put log mod x, and that is sin of y by x is equal to log x plus c. Now, to find the value of c, we have to use the condition that when x is equal to 1, y is equal to pi by 6, because 1 comma pi by 6 is given to lie on the curve. So, therefore, if we put y equal to pi by 6 and x equal to 1, we get sin pi by 6 equal to log 1 plus c. Log 1 is 0 and sin pi by 6 is half. So, this implies c is equal to half. Therefore, sin y by x is equal to log x plus half. So, this says that option A is the correct answer and B, C and D are wrong. So, this was an example of an ODE which is in the homogeneous form. Let us do question number 4. Let f from 0 infinity to r be a differentiable function such that f prime x is equal to 2 minus f x by x and f 1 is not equal to 1, then which of the following options is or are correct? So, first option is limit x tending to 0 plus f prime 1 by x equal to 1. B is limit x tending to 0 plus x times f 1 by x equal to 2. C is limit x tending to 0 plus x square times f prime x equal to 0. D is mod f x is less than equal to 2 for all x belonging to open interval 0 2. So, what we are given is an ODE. Write y equal to f x, then we have f prime x is dy dx is equal to 2 minus y by x, and this can be rewritten as dy dx plus 1 by x times y equal to 2. So, this is linear ODE. So, we know how to solve. In fact, in this case if you multiply this by x, this gives x times dy dx plus y equal to 2x, and now you can clearly see that left hand side is nothing but the derivative dy dx of x times y equal to 2x. Then by integrating this we get x times y equal to x square plus c, which implies y is equal to x square plus c divided by x. So, this can be written as x plus c by x. So, that is f of x is given by x plus c by x. Now, we are given one more condition, that f of 1 is not equal to 1. So, this implies f of 1 is equal to 1 plus c, and since f of 1 is not equal to 1, we get c is not equal to 0. So, therefore, we have f of x is x plus c by x for some c not equal to 0. Now, let us look at the options. So, option A says the limit of f prime of 1 by x as x approaches 0. So, let us calculate. So, what is f prime of x? F prime x is equal to 1 minus c by x square, which implies f prime of 1 by x is equal to 1 minus c x square. Now, as x approaches 0, this approaches 1 as x approaches 0 plus. So, therefore, option A is correct. So, option A is correct. Option B is saying limit of x times f of 1 by x. So, let us calculate what is x times f of 1 by x. This is equal to x times f of 1 by x will be equal to 1 by x plus c x, which is equal to 1 plus c x square. This approaches 1 as x approaches 0 plus. So, option B is saying that this limit is equal to 2. So, this is wrong. So, therefore, B is wrong. Option C is asking for x square times f prime x limit as x approaches 0 plus. So, we have already calculated f prime x. So, x square times f prime x, this is equal to x square times f prime x is 1 minus c x square, which is equal to x square minus c. So, therefore, limit of x approaching 0 plus x square times f prime x is equal to minus c, and we know that c is non-zero. So, minus c is not equal to 0, but option C is saying that this limit is equal to 0. So, this is wrong. So, here note that f prime x was already known to be 2 minus f x by x. So, one may try to multiply this by x square and then try to find the limit. Note that since f prime x is equal to 2 minus f x by x, x square times f prime x will be equal to 2 x square minus x times f x. Now, here you can make mistake and think that as x approaches 0, this 2 x square approaches 0 and then we have x times f of x. So, of course, x approaches 0 and then you might think that x times f x also approaches 0 and so mistake. Thinking that limit x approaching 0 plus of x f x equal to 0. This need not be true because this limit of f x as x approaches 0 might be infinity or minus infinity. So, limit f x as x approaches 0 plus, this need not be finite. So, if you thought that this limit is equal to 0, then you will think that option C is correct, but it is not correct. So, now let us look at option D. So, option D is saying that mod f x is less than equal to 2 for x between 0 and 2. What is f x? F x is x plus c by x. So, f x is equal to x plus c by x and c is given to be non-zero. So, since c by x, this approaches infinity as x approaches 0 plus. Therefore, f x is not bounded on the interval 0 2. So, therefore, option D is also wrong. So, we get D is also wrong. So, only option A is correct option here. Let us do question number 5. Let y prime x plus y x times g prime x is equal to g x times g prime x or x in R, and y 0 is equal to 0, where g x is a given non constant differentiable function on R with g 0 equal to g of 2 equal to 0. Then the value of y of 2 is what? So, what we have is dy dx plus g prime x times y is equal to g x times g prime x. So, this is again you see that this is linear. So, what we do is we find first integrating factor e to the power integral p x dx, p x is g prime x dx. So, this is equal to e to the g x. So, we get e to the g x is an integrating factor here, and then we multiply by e to the g x and we get y times integrating factor e to the g x equal to integral of integrating factor e to the g x times the right hand side is g x times g prime x dx. Now, to integrate this, we use integration by parts. Integration by parts. Integral of, we will write this as g x times e to the g x g prime x dx. This is equal to integral of g x times d e to the power g x, and then by integration by parts, this is equal to g x times e to the power g x minus integral of g prime x times e to the g x dx, which is equal to g x e to the power g x minus, this is nothing but derivative of e to the power g x. So, this gives e to the g x plus c. So, therefore, we have y times e to the g x is equal to g x minus 1 times e to the g x plus c, which implies y is equal to g x minus 1 plus c e to the minus g x. Now, using y at 0 equal to 0, this implies 0 equal to g of 0 minus 1 plus c times e to the minus g of 0. G of 0 is given to be equal to 0. So, this is equal to 0 minus 1 plus c, which implies c is equal to 1. So, therefore, y is equal to g x minus 1 plus e to the minus g x. Now, we need to calculate y at 2. So, y of 2 will be equal to g of 2 minus 1 plus e to the power minus g of 2. G of 2 is given to be 0. So, this is 0 minus 1 plus e to the 0. So, this is equal to minus 1 plus 1, which is 0. So, therefore, y 2 is equal to 0. So, again this problem was a first order linear ODE. So, we can easily solve this. Let us do question number 6. Let f from 0 infinity to r be a continuous function such that f x is equal to 1 minus 2 x plus integral 0 to x e to the power x minus t times f of t dt for all x belonging to 0 infinity. Then we are given 4 options. The curve y equal to f x passes through the point 1 comma 2, B is the curve y equal to f x passes through the point 2 comma minus 1, C is the area of the region R equal to x y belonging to 0 1 cross R, such that f x is less than equal to y is less than equal to square root of 1 minus x square is pi minus 2 by 4, and option D is the area of R is pi minus 1 by 4. So, in this case we are given a function f which satisfies this given equation. Here if we see, we do not have a differential equation. So, what we are given is f x is equal to 1 minus 2 x plus integral 0 to x e to the power x minus t f t dt. So, first by putting x equal to 0, we get f of 0 equal to 1, because this integral is integral from 0 to 0, which is 0. So, f 0 equal to 1, this is one thing we get, and we can write this f x as 1 minus 2 x plus, you see this integral is with respect to t. So, this e to the x comes out of this integral, and then we have integral from 0 to x of e to the minus t times f of t dt. So, actually here what we have is called an integral equation, because we have a function and integral, but by differentiating this we can get a differential equation. So, differentiating with respect to x, we get f prime x is equal to minus 2 plus, to differentiate this we will use product rule. So, we have e to the x times 0 to x e to the minus t f t dt. This is by differentiating the first term, plus e to the x times the derivative of the second term is simply e to the minus x times f x. So, this gives f prime x is equal to minus 2 plus, this again I can write as 0 to x of e to the x minus t f t dt plus f of x. Now, this integral is nothing but f x minus 1 plus 2 x. So, this I will write as minus 2 plus f x minus 1 plus 2 x, and then we have plus f x. So, this gives f prime x minus 2 f x is equal to 2 x minus 3. Now, this is a linear ODE. So, what is integrating factor here? Integrating factor is e to the power integral of minus 2 dx, which is e to the minus 2x. So, by multiplying by e to the minus 2x, we get d dx of e to the minus 2x times f x is equal to e to the minus 2x times 2x minus 3, which implies e to the minus 2x f x is equal to integral of 2x minus 3 times e to the minus 2x dx. This again we integrate by parts. So, this is equal to 2x minus 3 times e to the minus 2x by minus 2 minus integral of derivative of 2x minus 3 gives 2 times e to the minus 2x by minus 2 dx. So, this is equal to minus half 2x minus 3 e to the minus 2x. This becomes plus e to the minus 2x by minus 2 plus c. Multiplying by e to the 2x, this gives f x is equal to minus half 2x minus 3 minus half plus c e to the power 2x. So, therefore, f x is equal to c e to the power 2x minus x, and then we have plus 3 by 2 minus half, so plus 1. Now, we have calculated f of 0 is equal to 1. So, this implies 1 is equal to c plus 1, which implies c is equal to 0. So, therefore, f x is equal to 1 minus x. So, we get f x is simply 1 minus x. Now, let us look at the options. So, the first option says that the curve y equal to f x passes through the point 1 comma 2. So, what is f of 1? F of 1 will be 1 minus 1 equal to 0. So, the curve passes through the point 1 comma 0, not 1 comma 2. So, option A is wrong. Option B is passes through the point 2 comma minus 1. So, what is f of 2 is 1 minus 2 equal to minus 1. So, therefore, B is correct. So, option B is correct. Option C and D are asking to find area of this region. So, what is the region? Is y is between f x and square root of 1 minus x square. So, this region R is x y belonging to 0 1 cross R, such that f x is 1 minus x is less than equal to y is less than equal to square root of 1 minus x square. We need to find what is area of R. So, if we look at this region, if we look at y equal to 1 minus x is this straight line which passes to the point 1 comma 0 and 0 comma 1, and y equal to square root of 1 minus x square for x between 0 and 1 is this circular arc. This is y equal to square root of 1 minus x square, means x square plus y square equal to 1. So, this is the circular arc of radius 1. Now, this region is for y, region is bounded from above by the curve y equal to square root of 1 minus x square and from below by 1 minus x. So, the region is this region. So, here you do not even have to integrate to find this area, because this area of R is nothing but the area of this quarter circle minus area of this triangle. So, this is 1/4 times area of circle of radius 1 is pi 1 square minus area of this right angle triangle is half times 1 times 1. So, this is pi by 4 minus half, which is equal to pi minus 2 by 4. So, option C is correct, D is wrong. Therefore, C is correct, D is wrong. So, this problem shows that sometimes the equation is not given in terms of derivative, rather it is given in terms of integral. So, it is an integral equation, but by differentiating this we can convert this into differential equation, and you have to find some initial condition. So, here by putting x equal to 0 we got f of 0 equal to 1, and then you get a first order differential equation with some initial condition, and then you can solve that to solve this given integral equation. All right. So, this finishes lecture 5 on integral calculus. In the next lecture, we will do some more problems on differential equations. Thank you.